In this video, I'll show you how to build random forests in scikit-learn in Python, and for that I will be using Prython 2.0 as my IDE. Prython allows me to code both in R and Python by just adding panels like this and then putting my code in there. So in order to run this example, you need Prython that you can download it from www.prython.com. It's available for Windows only, and you can download my project random_forest.prython from the following GitHub repo over here. I will clean everything just to show you how this works. So what I will be doing is to load two data frames that we'll see in a minute. I will import a few things, then I will merge the two data frames together. I will filter some of the variables that I don't want. I will transform everything into NumPy array that I will call X. Then I will create dummy variables that I need for a variable that will be a country, and then that's really it. So then I will join these two together. Then I will concatenate here by columns, and I will concatenate the NumPy array plus the dummies that I generated. So let me explain how that works. I will run everything now. Now run below. Let's see how that looks like. You see that the data frames that are generated in any panel get loaded next to the panel that created them, so that's very cool. And now we'll show you how that looks like. And also you will see that this got filled. These are the NumPy arrays that got detected, that were available up to here. So let me explain that. So I first loaded my data, so mobile desktop. This is the data frame that I wanted, and the other one that's main data. So in main data we have data for users in a website. So we have the name, the IP address, the profession, job title, time since registration, purchases last month. So we have a few things. And then we have a column that is VIP client. So what we want is to build a classification model using random forests to predict this. So before doing that, I also need to load another data set that has extra information, which is mobile_desktop, that I loaded from here. By the way, both of them, you should get them from the GitHub repo I mentioned initially. And the idea is to merge the two of them together. So you see the panda.merge that create merge data, which is this one over here. And obviously has a lot of columns, and yeah, I don't need all of them. So I will filter a few of them, and that's what you can see here. So at the end, I ended up with mobile or desktop, country, times login, age, time since registration, purchases last month, and is VIP client. Remember that the objective is to predict this is VIP client, and the other variables will be the features that I will use in a model. Before doing that, I need to work with the country codes because these are just strings, and I need to transform them into a dummy, a set of dummy variables that are 0 or 1. So what I did here was to transform this using the corresponding function in pandas.getDummies, and as you see, a few of them are 1. For each row, only one column will be 1. And that's really it. Now I have everything that I need. Bear in mind that here X does not include the country, as you can see. I have removed it. I am working with the country to get the dummies, and then I will join the two of them together in a minute, as you can see there. So the way I run an extra tree classifier or random forest classifier in scikit-learn is very easy. I just imported everything in there with just that line. That was easy. And then we call the function, the constructor, which is ExtraTrees classifier or random forest classifier. And then we call the cross-validation score. So cross-validation essentially creates multiple blocks in our data. So let's just say it creates 5 blocks, it grabs 4 of those blocks, and it predicts on the 5th one. And it does that iteratively by taking 4 blocks, 4 blocks, 4 blocks, 4 blocks, and predicting on the other one. So here what we get is this scoring rock AOC. So this is the area under the curve. 0.5 is not a great value, and a 1 is a great value. So this works kind of okay, so not that bad. And the same thing for the random forest classifier. These windows that you can see here, these are comments that I just added by adding their note, and you can put whatever you want in there. Let me show you a final thing. So one thing that I did here was to add the two models together like this, so I can experiment. So I can see how both models work by just pressing in here, run below, and everything will run fine. So one extra thing I can do that is pretty fun in here is that we can run different experiments and store them. So for example, one thing I could do is to change a parameter here in the random forest classifier. There are many parameters that we can change here, or hyperparameters that we can change here. I will modify the most famous one, which is the max depth. By default, this is a random forest. A random forest is built of trees, so trees, classification trees, and scikit-learn will build those trees to be as dense as possible, as dense as it needs. One thing that we usually want to do is to trim this, or to put a ceiling or a maximum value for the maximum depth of the tree, because to some extent that generates overfitting. If we had a tree that had a perfect ability to grow, it would be just too big. It will work perfectly for the trained data, but then when we feed this with new data, it won't work so well. So by default, this max depth is equal to any value. It will be as big as you want. So in practice, we usually put a value like 5, 6, 10. We usually never use something bigger than that. So let's just try with 5. So one thing I can do obviously is press here, and that will run everything below. But just to show you how this works, one thing I can do is click on run up to here, and that will only run this branch of the experiment. It won't be running this one. So it will be more efficient and it will take less time. So there we go. There we have an experiment. So you might be wondering, wait a minute, how can we store the different results? Because it's easy to forget what we had before. So one thing we can do is to freeze the output. So there I froze my output, which looks great. And let's just change this to some other value. Let's just change it to 10. I just run everything again. So you see the panel got scheduled, panel started, panel finished. You see a CPU jumping to 61%. That was quite amazing. So there we have the result, and that's it. We can freeze as many as we want, so we can do lots of experiments there. Another possibility that you can use here is you can copy the current output like this. So if you copy like this, you might want, for example, to copy 2 different models and just have them there, and you can see them once against against the other one. If you had more panels, more models, let's just say we're testing 10 different models, we could copy all of them, put them all next to each other here, and we can see the results, and that's pretty awesome.